Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be studying Section 4 of Chapter 4, Linear Inequalities in Two Variables. The first type of problems we're going to take a look at is determining if something is or is not a solution of an inequality in two variables. So if we look at number 1 from problem 1, it says, is the ordered pair a solution of y is greater than x minus 3? So part A gives us the ordered pair 1, 2. So what we're going to do, an ordered pair is the same thing as x and y. I'm going to replace x with 1 and y with 2 in the inequality given and see if it works. So y is 2, and I want to know if that's greater than x is 1 minus 3. Simplify. Is 2 greater than negative 2? 2 is greater than negative 2, so yes, this is a solution. Now, in part B, we want to see if the ordered pair negative 3, negative 7 is a solution. So using the same inequality, y is greater than x minus 3, I'm going to plug in x is negative 3 and y is negative 7. So is negative 7 greater than negative 3 minus 3? Simplify. Is negative 7 greater than negative 6? No, it is not. So no, negative 3, negative 7 is not a solution to the inequality y is greater than x minus 3. So now I want to talk about graphing linear inequalities. When you graph a linear inequality, you can either use a dashed line or you can use a solid line. You're going to use a dashed line whenever there is not an equal to in your inequality. So for example, it's strictly greater than or less than in your inequality symbol. However, anytime you have an or equal to, you will use a solid line when you graph your inequality. Now, the other difference is that in also determining whether you use a dash or a solid line, you're also going to have to do some shading when you graph linear inequalities. You will shade above your line anytime you have a greater than symbol in your inequality, whereas you will shade below your line anytime you have a less than symbol in your inequality. So when we get ready to graph here, we're going to have to pay attention if we're going to have a dashed or solid line and which way we're going to need to shade our solutions. So the best way to see how this works is just to look at some examples. So our first example under problem 2, number 1 says, what is the graph of y is greater than x minus 2? So to graph an inequality, I'm going to graph it very similar to an equation. I'm going to make sure it's in slope-intercept form, y equals mx plus b, and I'm going to first plot my y-intercept. In this case, my y-intercept's at negative 2, so I'm going to plot a point at negative 2. From my y-intercept, I'm going to count my slope, the coefficient in front of x. In this case, that's 1. So I'm going to rise 1, run 1. Rise 1, run 1. Rise 1, run 1. I'm doing my best on this to get the point to fall where I want it. And then I'm going to connect those points to make my line. Now since this is a greater than, no equal to, these points are going to be connected with a dashed line. So I'm not going to fully connect my line, I'm going to dash it. And then I also need to do some shading. Since this is greater than means I'm above, I need to shade above my line. So the inequality would look like so. I have a dashed line at y equals x minus 2, and then I'm shading above the line to represent all of those points I shaded towards are solutions to this inequality. Our second example, we're going to graph the inequality y is less than or equal to 1/2 x plus 1. So what I want to do, I want to start by making sure my inequality is in slope-intercept form, which it is, and then I want to plot my y-intercept. So according to this inequality, the y-intercept's at 1, so I'm going to plot a point at 1, and then count my slope. Up 1, right 2, because that's the coefficient in front of x. So up 1, right 2, up 1, right 2, up 1, right 2. Again, on this program, I'm getting as close as I can. You should hopefully on your paper be able to get exactly where you want it. And I'm going to connect these to make my line. Now, since my inequality has an or equals to, that means this is going to be a solid line. Sorry, it's so bumpy. And then I need to shade either above or below. Since this is less than, we shade below our line. So my graph, I made the line, and then I'm shading below to represent all those points I just shaded towards are also solutions to this inequality. Now, in addition to graphing inequalities, we can also write the inequality given a graph. So we're going to jump to the next problem, problem 5, that says write an inequality to represent the graph shown. So we're given this picture, and when you write an inequality, we want to know the y-intercept, we want to know the slope, which I'll just use m to represent slope. Now, the y-intercept is the point where we cross the y-axis. In this case, where I made the red dot, that would be at 1. I'm not going to worry about writing it as a point because we're just writing the equation. And my slope, I need to count the rise and the run between any 2 points. So I'm going to say I rose 2, which is positive, and I ran 1, which is positive. 2 over 1 would give me a slope of 2. Now, using this information, I'm going to write my inequality. So our inequalities are written, y equals mx plus b, but instead of equals, it's going to be an inequality symbol. So I write y, I leave a space, m was 2, times x plus my y-intercept was 1. Once I've plugged in my slope and my y-intercept, I then fill in my inequality symbol. I look at what type of line I have. I had a solid line, which means I should have an or equals to. And I look at which way I shaded. This one shaded below. So since it's shaded below, this would mean that this is a less than. So the appropriate inequality to go with this picture would be y is less than or equal to 2x plus 1. Pick out your slope and y-intercept and then worry about your inequality symbol. The last problem we're going to take a look at is number 2 of problem 5. Write an inequality to represent the graph shown. So what I'm going to do to write my inequalities, I need the y-intercept and I need the slope. So the y-intercept, where across the y-axis, right there, that would be at 0 for this dashed line. And my slope, counting between any 2 good points, I rise positive 1, I'm running positive 3. So my slope is 1/3. So once I have my slope and y-intercept, I'm going to write my inequality. Y, leave a space for the inequality, mx, 1/3 x, plus b. When your y-intercept's 0, you don't need to put plus 0, so I'm just going to have the y and the 1/3 x. Now I need to put my inequality symbol in. This was a dashed line. That means there is no equals to. It's strictly greater or less. So if I look at which way we shaded, this one was shaded below. Anything that's shaded below is a less than. So the inequality symbol to go with this graph is y is less than 1/3 x. This concludes our lesson on being able to graph inequalities in 2 variables and write the equation of an inequality in 2 variables. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.